All right, here we go. Hey, this is our Talking Energy podcast, Talking Energy show. I'm Matt Hill. I'm with Night Energy Services.
Jeremiah Smith, Mito Resources.
Cody Godsel, almost with a small operator here in town.
Not going to announce it live on air yet?
Not until it's 100%.
Okay.
You should get a paycheck first.
Yeah.
Your turn, buddy.
I'm Seth Sleeper with Barrel Energy Solutions.
All right, well, that's it. We are on the Talking Energy show now, and we're going to tell you guys all about our guests. And, well, you guys are going to tell us about yourselves. Cody, how did you get into the oil and gas business? Like, what got you here?
Ever since I was in middle school, I probably knew I wanted to be an engineer. So I decided pretty early on that I was going to go to an engineering school.
How did you know that?
Yeah.
My teachers told me, I guess. I was in some advanced classes even in middle school, and they're like, you really need to pursue the math and the sciences and go that route. So that's kind of what I was set on. It's what I enjoyed. I was always in advanced science and math classes in high school, and I knew I wanted to get out of South Dakota. That's where I grew up. So I went to Colorado and toured the Colorado School of Mines, and my tour guide happened to be a petroleum engineer, and they told me all about what they were learning. I think they were a sophomore at the time. I went in undecided, did my first year of college, and then started talking with different faculty in the petroleum engineering department, and decided to enroll in the petroleum engineering program, and that's kind of how I got into it. No family background, no nothing, just jumped in.
No oil and gas background in your family at all?
Nope.
Man, so Cody, thank you for telling us a little bit about your past. What do you enjoy doing in your free time? What is something that's a lot of fun for you to do?
I like to go fast. I like to race cars.
Oh, you race cars?
Yeah.
No way.
Yeah, I think I've seen you out there.
Are you ever are you on a team with somebody maybe?
Yeah,
You
dude.
could call it a team, but
It's a group of similar, like-minded people trying to finish a race.
Is Jeremiah
Yeah.
just as bossy out there on the track as he is in here sometimes?
you know what? I tend to be more bossy out on the track.
Oh.
But
Look at him.
Jeremiah just kind of goes and gets shit done.
Man,
I just yell
he
at people.
does. He's the
Sometimes, heck, you did all of this.
he's the GSD of many things for sure.
What is it, GSC?
GSD. You're the
Get stuff done.
Oh,
Get-
I have not actually heard that acronym.
I didn't either.
Oh, well, there you go. Hey, a new acronym for every you. Follow the hashtag GSD. We'll
GSD.
start including that.
Boy, no, we should check into what else uses that hashtag. Just seems like a lot of times I get
Trying
you
to
in
think
trouble.
what it could be.
Yeah.
ESG GSD right here on the Talking Energy Show. Hey, Seth, man, I've known this guy. We got to know each other when you were in college because you were always involved in oil and gas industry advocacy groups in college. So tell us about yourself and how you got into oil and gas.
Yeah, so similar to Cody, I grew up kind of focused on wanting to get into engineering. I grew up racing sprint cars like you guys like to go
shit.
fast.
Oh, no, I had no idea that.
Yeah, 5 to 15, I was racing dirt track sprint cars.
Why would you ever stop? That seems like such a good time. That's the one with the inverted wings?
That's right.
where one up, one down?
Yeah, so whenever I was on a team where the kids started dropping out of high school to travel, and one of them is actually in NASCAR now. I don't know if y'all know him, Christopher Bell. He's from Norman, Oklahoma. But
Christopher, would you like the Talking Energy Show logo on the side of your car for the low price? We can give it to you.
that would be sweet. So I decided, no, I don't really want to do that. I saw the writing on the wall that this becomes a really expensive hobby or it turns into a career. So
Definitely expensive.
I really enjoyed the hands-on type learning stuff. I just graduated out of high school. I was like, I know I wanted to do engineering. I'm not sure I'm ready to go to a big college. So I went to Rose State for a year, figured out, I could do this. And then I transitioned up to OSU, and I transitioned into every engineering discipline, just trying to figure out what I wanted to do. I really didn't really know what that was, but my last semester, my mechanical degree, I enrolled into a drilling and completions course, and that was just, I enrolled in it because I knew if I enrolled in that, I only had to be on campus one day a week. So I got into that, and I really quickly figured out that, not only one was this some of the most interesting subject matter that I had experienced in college yet, that getting around the industry professionals and those professional societies, it was just like, check both of those boxes, like something I'm interested in, people I like being around.
Oh, it's a fun industry. Man,
Yeah.
it's fun.
Incredible. So I got into SPE at OSU, and I told my professor, I'm gonna stick around and finish out this minor. And he was like, I'm bringing on some grad students next fall if you're interested. And I was like, that's not for me. I'm not sure I can really afford that. And he's like, I'll pay your tuition and I'll give you a monthly stipend.
No way.
I was like, I'll see you next semester. So enrolled into grad school, and it was specifically for petroleum engineering. And I wrote a thesis on PDC ROP modeling for the Department of Energy. And just through that, I quickly started looking for opportunity to get into the industry, and had an internship with Altera Drilling Technologies here in Oklahoma City. And then
Great people.
yeah. And
Michael's awesome. Michael Thomas.
yes, that's a barrel.
He's at Barrel now, but he had an internship. I am following along for those
Awkward.
that are watching.
Sorry, I'm a little long-winded.
Yeah.
No, but transitioned into started getting into SP a little bit. I ended up being the SP student chapter president.
For those that are watching outside of our industry, we have a lot of advocacy groups, and we start them off young in colleges. So what's the SPE part of that?
Yeah, so the Society of Petroleum Engineers at OSU is really just targeted into getting our students into networking opportunities with oil and gas professionals. So
Get you hired.
yeah, I mean, there's not a whole lot of eyes on OSU in terms of having OU and Tulsa in the state of Oklahoma with really renowned petroleum programs. So it's a feat in itself trying to make networking opportunities occur through OSU. So
You guys were good at it. You always had me up there cooking out, or I always enjoyed the golf tournament and clay shoots, bringing you guys on. That's a lot of fun. I'm glad you guys were able to. It seems like more of your students are involved. Is that because of you?
Well, I did annoy a lot of them. So a lot of them know that if they're interested in getting into the industry, they need to be, because they're not. I guess your oil and gas companies aren't really showing up to the career fairs at OSU. You really got to be pounding the doors down and creating networking opportunities for them, and it really is one of the main avenues for OSU students to get in front of oil and gas industry professionals. So, I mean, you got to create those opportunities, because they're not really there for you in terms of.
You're one of the best, and you got it early on to get out there and network. Cody, you're the same. What was your first job out of college for the oil and gas industry?
Straight out of college, I was with Chesapeake Energy.
Right away.
Yeah, I was with them up until February, and then been on the hunt ever since, and about to land a new gig here, hopefully starting next week.
In my head, I was going to get you on and get you hired. So right after this, if you hire him, thank you, Talking Energy Show. Thank you, Jeremiah.
Yeah, we did that.
You're welcome.
Take all the credit.
Yeah, if you want to buy us a bottle of Woodford and put it on our desk every now and then, we'll take it. We encourage all of our podcast guests to bring us bottles of whiskey for us to enjoy in this. Or if Woodford would like to sponsor.
Yeah, Woodford, please. We're still looking for that first sponsor of whiskey. So
Might as well.
really holding out for McAllen.
Bland's.
I do
Bland's
Bland's.
would be
Yeah.
That'd be sweet.
Yeah.
Lead Slingers, all the good ones. Cody, how many wells did you drill at Chesapeake, do you think?
Oh gosh, a couple hundred. I don't really know.
So you're seasoned now.
Yeah. I worked all over the United States: Haynesville, South Texas, Powder River Basin in Wyoming, and in the Marcellus for a very short stint.
I was thinking that was Utica. It was actually the Marcellus that you were in, huh?
We sold the Utica probably 3 years before I got over there.
So are you guys still doing monobore? And they were when I was at Chesapeake. And I'm pretty confident. Like, they were trying to just rotary steerable. They would air drill down, set a liner, and then try to drill the horizontal and the curve and the horizontal in one run.
Yeah, I think they were doing that in the Utica, a little bit easier drilling. Honestly, it's escaping me right now on what we were doing for those last 6 months I was there. So I'm remembering all the other ones, the Powder River and the Eagleford, but
It was cold. It froze into your mind.
yeah.
But you got to go hit the slopes while you're up there a little bit, right?
Yeah, that was a big perk about Powder River. Every time I would fly in, I'd fly into Denver and hit the slopes over the weekend and then go up to the rig.
Man.
It was great.
Man, have they figured that out? Like, and I guess you got to speak a bit vague, but I was at Chesapeake and I actually worked for their oil field services division from 12 to 16. And it just seemed like the Powder River was that basin that still needed a lot more engineering. Like, it was pretty far from being good.
Yeah.
We set a lot of reserve strings of pipe, and we did a lot. We left a lot down there. We left a lot of jewelry in the hole. It was the kicks and all that. So
yeah, when I was there, we definitely didn't have it figured out. Chesapeake is kind of cursed with some very hard to drill acreage. They're right at the basin boundary on the south side of the field, so they've got tons of faulting and fracturing that makes drilling out there a lot harder than it is for their peers up north. So
when you were at Chesapeake, did you guys talk a lot with the next step, from drilling to completion? Were you in meetings with them and then reservoir guys and geology?
Yeah.
So you guys talked a lot about those basins. I mean, we've talked about it before. What's it going to take for Powder River to just take off again?
It's a good
Any
question.
ideas?
No,
Infrastructure is a big thing. They don't have a
Yeah.
lot of pipeline.
Yeah.
Yeah, so they're flaring a lot of gas up there and stuff. They don't have a lot of infrastructure at all. It gets even worse as you go west. Like Utah has none at all.
Yeah.
But it's a huge issue up there. So their costs are substantially higher for a multitude of reasons. One, it's cold, right? You brought up, so they got to have a rig that's insulated and has boilers and stuff like that. That's quite a bit more cost. And then it's
you have to have sometimes heat your water lines or heat your big, they call them Poseidon tanks, but couple thousand barrel tanks for water.
It's all the way from the water source to the rig and
Yeah.
using it. It's got to be heated the whole way.
Almost
water
every
is a pain too, I believe.
Yeah, getting it. Yeah, so you can get it from the municipality, or you can, which I think you just pull it out of the river nearby, or you can truck it in from somewhere else.
I did a project last year, and Wyoming regulatory is great to work with. I'll tell you that they're very pro oil and gas, which is awesome. But drilling it, we would drill a salt water or a well on location to get our water, just because we weren't close enough to any type of water source. But water scarcity, and this was by Cheyenne, so southeast. But it was a hurdle to overcome, and it added a lot more cost once again. And you just don't have the vendors.
Yeah.
Right, you don't have those relationships because it's a newer. I don't know if it's newer, but the horizontal play there.
It was like booming when Niobrara, they first found that out up there, and then that kind of wasn't working out, so everybody left. And when we started coming back for the Turner and
Parkman.
Yeah, some Parkman. We were actually planning on Parkman. We hadn't done any yet. But when we came back for the Turner, there just weren't that vendor base. We had to kind of beg and plead and get stuff from Rock Springs or get stuff from Cheyenne. Just not a lot nearby anyway.
Now, where's the Turner and the Parkman as compared to the Niobrara?
So Turner is below the Niobrara, like directly below. And then the Parkman is a few thousand feet above it.
Yeah, so they're actually spending more money to get to the Turner below, and probably more hazards along the way.
Especially with depleted Niobrara. After you've drilled and produced it, and you go in and try to drill a Turner that's overpressured now from what your Niobrara was, it makes for a tricky situation.
Oh, the pressure differential when you cross into the other.
Well, yeah, now that you've
other
depleted
rock,
Niobrara,
yeah. So you'd have to mud up or something.
set
right?
another string of casing.
Yeah. Yeah, and that's in your curve. So I did a couple of those where they tried to do it without setting another more casing at like 45 degrees. But the problem with that is it was so unbalanced between the two different rocks. So
Yeah, we had a handful of hole collapse issues right there in the Niobrara because of that unbalanced right there. So one of the biggest problems that we had, really.
When you got to Chesapeake, did they put you through all of the different,
Disciplines?
disciplines of engineering? Right?
Yeah, so not really. When I got there, their training program was a little bit different. I started in 2013, and I went directly into drilling engineering. And the plan at the time was to do a year to a year and a half on a rig, just kind of being a third company man. I would do 2 weeks in the field and then go home for a week and then go to the office for a week and then repeat that for a year to a year and a half. So about halfway through that, they started doing a rotation program where they would then bring new hires on as field engineers, and they would do 4 months in drilling, 4 months completions, 4 months in production, bring them into the office, and then rotate through completion, production, reservoir, and drilling 3 months apiece. So after I had come in, they got a really good diverse training program there. Almost. And
That's what I got that new desk for.
it needs a little covey to catch it.
I need a
Yeah, a
catcher.
little pillow over there.
luckily I was able to talk my boss into at the time to get a little completions experience in the field and a tiny bit of production experience. Kind of rode around with a pumper for a couple weeks. But
Nice.
You know, being at Trace, that's always a big issue. So finding a jack of all engineering disciplines is very difficult because it used to be a thing where smaller entities, this guy would do drilling, he would do their facilities, right? He would design everything too. But now they're more siloed. It's really difficult to find a guy that can handle all the different facets for these smaller entities that can't afford to have 3 or 4 engineers, right?
Yeah.
There's just not that many out there.
yeah, I'm looking forward to that. Going into this small operator, hopefully getting to wear a couple different hats. I'll be a drilling engineer over there, but who knows if I can help out with completions or learn some stuff about production facilities too. So
Yeah, facilities is like a whole nother animal that
Yeah.
you never really hear about, but it's integral, of course.
of course.
Hey, Seth. So, what is your thought on our community colleges in Oklahoma?
Oh, I think they're a great stepping stone. I
Yeah?
did it myself.
I know. That's what I'm asking, man. I did
Did you
too,
get all of
actually.
your basics in there?
Kind of. The moment they told me that stuff wasn't going to transfer, I was like, see you later.
Yeah.
Yeah.
So,
Yeah, that's the same thing. I did that, and I was really happy I did. And unfortunately, I was kind of oblivious to it till my second year, where I would have done my first 2 years at the community college, because actually it was quite difficult. I enjoyed it. Good professors, smaller class sizes. I guess I'm just advocating for it here. Save some money and help out the community colleges.
I wonder
It's
how
great
many
experience.
colleges we have in Oklahoma, including the community colleges.
Oh man, I don't.
100?
Yeah, it is crazy. I can't even tell you all of them in Oklahoma City, the community colleges.
And every one of them should have like something to do with, like they need a course on oil and gas, just basics, right? I mean, everybody in Oklahoma is somehow involved in oil and gas.
Intro
whether
to
they know it or
energy.
not.
Definitely.
Intro to energy.
Yeah,
You could teach that class. You'd be a great
I did
teacher.
get an energy minor in college. So.
There we go.
Do you have a petroleum engineering degree? What the fuck is an energy minor?
So
You can cuss on the show.
the
I'm not going to bleep that out, Jeremiah.
The energy minor taught me about like energy economics, world energy, just politics, I guess. And then also I took a class on renewable energy, I wanted to take a class on nuclear energy, but it kept getting canceled. I guess just not enough interest, but which kind of goes along with the current politics and everything.
I wonder if that'll change though, because I think people are starting to open their eyes, say, okay, we realize solar and wind is not going to be our saving grace.
I don't know if they realize that. That's the problem.
Were the professors teaching those courses just all about it? Like, were they pushing that agenda? Like, hey, by the way, when you're in my class, you should know that this is the future of energy.
No, not really. So my renewable energy professor was actually my physics 1 and 2 professor. Same
So he
person.
knows the physics, so
yeah.
he's like, this isn't going to happen.
Yeah, I mean, he gave it his all, and he was being unbiased, and he let us go out into the community and talk to different people. Like I went up to Winter Park and talked to them about how they're using renewable energy, which they're just buying wind credits and paying more for electricity on purpose. So,
Wait, explain that. Can you?
I can just briefly scratch the surface.
But
so
they were trying to offset their carbon
yeah.
by
So
buying the wind credits.
So they would buy wind credits and pay more for them. I think it was double what the background electricity cost was, and that just lets them kind of have a plaque up in their office saying we bought X amount of kilowatt hours of electricity from wind. So
Were they pretty dirty, that industry that you went and viewed? Did they have a big carbon footprint, I guess is what I'm
How
asking.
could Winter Park have a big carbon footprint?
I don't know.
well,
I'm
they
just
got the
trying to understand
generators
why.
and stuff in their lift houses and all that. So, but no, they were relatively
They're
clean.
locally
So this
sourced
was just
organic
someone's personal
generators.
goal to be green.
Yeah.
And to buy those.
They're Colorado
Yeah.
granola
Yeah, I mean
generators.
it's Colorado, it's Winter Park, so you got to appease your customers. If you got a bunch of liberals coming up to your ski resort, they're going to feel better about going to one that uses wind power. So it was probably just all PR.
I would love to see a ski lift run by wind power.
Oh, I know.
Just hang out up there.
Oh, darn it.
It'd be a catch-22, right? Because if it's too windy, you can't use the lift, and then if it's not windy enough, you can't use the lift.
Fantastic.
That
idea.
is not. That is just pretty much wind on its own.
Yeah.
You know. So
Put little sails on all the chairs.
And I don't mean to knock every time on this show, but it's always me trying to knock wind and solar somehow. I'm sorry, Jeremiah.
no, like I care. I'm a equal opportunist.
Show you the money.
Yes. Why am I doing this? Is it better or will it be better? You know, those are kind of investments I look at. But I certainly want to leave the earth better than I got it. So if there was a better alternative to petroleum, I would be all about it. But there isn't. So I'm all about petroleum.
Because you're, the next generation, was the idea in school that oil and gas was going to be a forever thing, or was there blowback already in your class saying, hey, we don't know if this will even be around, or like we don't like it?
No. So primarily OSU right now has a lot of
today.
It's time to fill it.
Hey, man, why don't you stop bogarting that ice over there?
A lot of the work that we were doing in my graduate studies was geothermal drilling. So they really did have a focus on renewable energy, but it was primarily for geothermal drilling. It's just uneconomical, so they wanted an ROP model that drilled hard rock, and they wanted a 1 foot ahead drilling model. That's probably too much. Sorry, Department of Energy. But so my small portion of it was just the rock cutter contact and what that looked like and how to model that kind of infrequency whenever you go to measure something like that. Because, digging with a single cutter on a really ductile formation, it's just models really smoothly because it's all constant contact. But you get into something like a really hard marble, and you go to do a VTL test, vertical turn lathe, and you just start.
I don't know that explaining the acronym did any good. By the
No,
way,
it didn't. I was like,
well, you know what a lathe is, right?
yes, I do actually. Yeah, yeah.
Vertical, and it's a turn. So
Vertical turn lathe.
Yeah, so that was something that surprised me. I started mentally thinking about the difference in a rock crushing bit, the tricone or button bit, compared to a PDC.
Yeah.
Which PDC is actually scraping.
yeah, shearing.
Yeah,
like a
shearing.
little shovel.
Yeah. Yeah.
Would it be a shovel?
Maybe not.
No.
I retract that.
Resoundingly no.
Maybe if you drag a shovel like that.
So drilling.
Hey, Seth,
engineers
next time
should
say,
or should not be
actually.
drilling bit professionals.
No, that was actually something interesting is getting into that kind of stuff. With writing a thesis, I had to go through a whole literature review of, just drill bit history, right? And there's some really interesting stuff to be learned there. And then, I don't know, the PDC thing just seems like it should have been probably the most intuitive from the get-go, but we have mechanical parts in a bit, and it's just, I know the fishtail bit is a kind of an early PDC, but
What is a fishtail bit?
it's pretty much looks like that guy, but with two blades.
Oh, okay.
Yeah, and they just drop it, and it's pretty much the same action as a roller cone with the crushing.
What changed it? Why did PDCs become practical? There had to been some innovation. Was it the buttons or the cutters, the tungsten? Aren't they tungsten carbide?
Yeah, it's just the efficiency. So instead of crushing the rock, you're able to shear it.
Right, but why did it take so long for that to be adopted?
Exactly. I don't know.
I can actually recall when it happened.
Was it cost?
Potentially. I'm not.
the
No way.
Just
There's
the
less moving
change-
parts.
just the
It's the
changeover
glue.
there?
What about the glue? Do you think it could have been the glue to hold the cutters in,
So I'm not sure about
or adhesive? I don't want to say glue. I don't know what it is.
for the roller cones.
No. Well, there's no glue on this on a roller cone. There is
press
on your
them.
PDC. Though.
Yeah, PDC. That's a so in metallurgy, that's a metallurgy process. It's called brazing. So you have they pretty much heat up this substance to a really high temperature, and it becomes a liquid. And at that point, it's what's pretty much providing a weld from one material to another, which being your cutter and your pocket on your PDC.
It's almost like soldering, right?
Yeah.
Well,
Yes.
when you say brazing, doesn't that imply that it's copper?
I'm not entirely positive on that.
Okay,
actually.
but that is not the solution or the adhesive or the weld material. The media is not a copper base. Or
I'd be lying to you if I took a stab at it, honestly.
yeah, no, we don't even have to go there. But tell me why geothermal? Where can you do geothermal, and why is it so inefficient in cost? Or why is geothermal not a bigger deal?
Yeah, so you have to drill to very deep depths to get the heat source that you need. So what they're doing is they're pretty much making a YouTube.
Very deep. It could be relative.
Right.
So Haynesville, that's pretty
It's
hot
hot.
rock,
Yeah,
and
it's
that's
hot.
Yeah.
12,000 TBD, 10,000 TBD.
Yeah,
Cody?
12,000.
Yeah.
It's roughly 350 bottom hole.
I know right now that you're seeing a lot of your geothermal projects happen in Utah.
Right, and California too, southern, I believe. But,
Yeah.
So
Do you know what
why
kind of
is that?
temperatures they're targeting for
Yeah.
downhole?
No, I don't. I know that the primary driver in that thing is injecting, or there's multiple different ways, but the one that we were introduced to is just injecting water from the surface, getting it hot, bringing it back to the surface, and taking that temperature difference. And
Was that
turning
two
it into
separate
energy.
holes or casing and tubing?
You could. They did it both ways.
Did they? Yeah, because you would lose heat on the way up, but you would gain heat on the way down.
Yeah, they tried a huge U-tube from two different well locations, and then also you could do a lateral type design with casing and stuff like that.
So I've actually heard someone here, I believe, is doing toe to toe.
yeah.
Trace management, by the way, everybody. We're plugging and plugged in right now. Thank you for the studio space, by the way.
Yeah.
That's not me.
Yeah.
Don't
No.
worry about that.
And Mido, of course.
I just ran it.
You got me in here. You got me into this mess in the first place.
So Seth, all right. So what is it? It's just the cost. You just can't. Does the reservoir cool after a while, or why would it not be? Or is it too isolated from civilization to move to turn that generator? What is it? The transmission of power? Why is geothermal not a bigger deal?
Yeah. So from my understanding, it was the initial cost of drilling the well, and then your payback period on that in terms of the energy you're going to get out of it.
ROI.
So you wouldn't have to actually perf or anything. You're just drilling a hole.
Yes.
Right.
And
Yeah.
using that median for the heat source pretty much. But I mean, really past that, I was really working on just a drilling model. The overall scope of the project was kind of lost in the translation to me. All I knew I'm working on a PDC ROP model, and it was just an interesting idea after the fact, learning about how new the geothermal space and how big it's kind of becoming from what I've seen online and stuff like that. So it was interesting, but yeah, the actual reasoning behind the project was a little bit lost to me.
So you don't know what the temperatures were required, like Cody had asked?
No,
Yeah,
I don't.
But it would have to be 300 degrees plus, right, or something?
Yeah.
Because the energy loss on the way out.
Yeah, I couldn't even venture a guess. I would say probably 350 to 500 they'd be targeting. And the hotter you get, you're not hearing me. The hotter you get, the more your tools are going to fail, the higher your costs are going to be. So
Oh yeah, I ran MWD. Actually, I
In the Haynesville?
I was the operations manager for Nomac Directional, and the Haynesville is very difficult drilling for multiple facets, but the heat is the biggest one.
Just because the rubber just melts.
Well, yeah, or solder joints.
Oh, solder.
No, yeah, because you're sending
MWD.
an MWD tool downhole. It's a lot of electronics. So you got battery temperatures there, and you have the normal problems with drilling a hole, the vibration and the torque changes. But on top of that, then you have heat, immense amount of heat.
Yeah, melt everything, see what happens.
It does. I've seen a lot of melted tools. It is incredible. The friction, right?
Yeah.
So you already have that heat in a normal hole, some of it, but you're really compounding it now that the hole is actually hot, not just what you're doing, not the work you're doing.
start getting battery failures
Man, the
too.
Haynesville the pay is just incredible on those wells.
Can
So,
be. Yeah, definitely. The gas
I mean, I
wells.
hope our whole industry is just working to design better, faster, stronger tools for, drilling down there because, oh my gosh.
The first thought that came to my mind, it has been at least 5, probably if not 6 years since I've been in charge of a directional company. And first thought in my mind, technology's got it. Because we invest so much in technology and oil and gas. I'd assume
Still not
there
enough.
is more of a solution. Am I wrong?
I've seen it get better over the years, and maybe it was just switching plays and stuff. But I mean, the motors seem to keep getting stronger and stronger, taking more differential, producing more horsepower downhole, and that just leads to other things breaking. You get giant motors that can produce thousands of foot-pounds downhole, and then all of a sudden your connections aren't strong enough to handle a stall downhole, and you end up twisting connections off or backing them off or something like that.
How much time did they spend in school with you guys on the actual tools that you're going to be using in the future out on your oil and gas careers? The motors and everything that goes with MWD and all that.
So my only class that did anything with tools was my drilling class, my junior year.
Not enough time.
No, it was one semester. Then we have a completions class after that, and it's focused on high level, what fracking is, acid fracking, all that stuff. So school, at least Colorado School of Mines, does a very good job of touching every subject. They do a better job of helping out with like reservoir engineering. They have a couple classes on that. They have petroleum economics. They have classes on artificial lift and things like that, but it's hard to teach the drilling and the completions because you really need hands-on, see it in the field. So
Did they use software? Good software base like torque and drag modeling and stuff like that for
We
why you run stabilizers? Yeah.
Well, not specifically for that. So we use like Gopher 3D. It's a frac modeling program, and then we use a little bit of Pason, and I think that was it in terms of software that we use.
yeah, we didn't do anything with torque and drag modeling in school. We did do like well control. We had a really nice simulator at
Thank
school, and they kind of run you through well control just like you would at Wild Well or something like that.
Seth, did you get that opportunity being a minor?
No. Really, the drilling and completions class so it starts off pretty much going through history. Like I think we talked about Kelly rigs for a third of the entire class, and then
You guys ever been on a Kelly rig? Either of you?
What's that?
Have you guys been on a Kelly rig?
No, I haven't.
No.
I have.
Really?
Oh man, I directional drilled on a Kelly rig. So we were very much spoiled with top drives.
Yeah.
You want to explain for the viewers what a
Yeah,
Kelly
what's
rig
a
is?
Kelly rig, everybody?
So instead of using a large mast that can control the RPMs and stuff that hangs in the derrick, a Kelly rig.
A big motor that hangs in the derrick.
Yeah, it is. And a Kelly rig actually uses what would you call that? A seated blocks that turn.
They call it the Kelly bushing.
Yeah, the bushings will turn, but you can't back out. You can't reverse on a Kelly rig like you can with a top drive. So why this is very important, And Kelly rigs are obsolete for a couple of reasons, but the big thing is when you're sliding, and that's when it's most relative why we need to make the swap, and trips too. But when you're sliding, I'll talk about trips too, but the sliding is a big deal because when you get going and you're laid out in a horizontal and you're trying to go, 10 degrees right or something like that. So just trying to bring it up and get a little ride in it. You will orient your tool face, and with PDC technology, you'll then start stacking weight on it. But with that, you get reactive torque, and it starts walking the tool face back. So you're trying to hold around 10 right. It's really quadrant based, somewhere between 0 and 45 degrees or something like that. It'll start walking. Oh, aren't you the guy that said everyone put that on silent? I don't feel like such a guy. Anyway, so when that reactive torque hits, you have to put more ride in it to offset it because that drill pipe. This is so crazy to think about, but this very heavy. What is it, drill pipe a foot?
19 and a half pounds.
Yeah,
It depends.
yeah.
I was thinking of like smaller, but
Yeah.
So either way, you got all this reactive torque, so you put more ride into it. And when I say right, you tell the top drive to turn a little bit to the right, just spin like you were tightening a connection. But after a while, you could lose your torque. There could be a stringer or something like that, or you could hit some type of ledge if you milled a window or something like that, and your pipe gets stuck on a connection. There's a myriad of reasons, but you lose that speed. And when you lose that speed and that deep cut with your cutters of a PDC, it'll start walking back the other direction.
Yep.
So to give you an idea, in a horizontal or a vertical, during a curve, when I get about 60 degrees, this is Mississippi up north, which we don't drill anymore, but when I did most of mine in Oklahoma, you would be flying through it, but after a while you would slow as you went through different rock, and then the bit would start walking back to the right. When it walks back to the right, you got to start taking all the wraps out of your top drive.
Going backwards.
Yes, but the problem is with a Kelly rig, it's very dangerous because they actually lock the blocks in place. So you have to pop the blocks.
And then it spins out.
It will. So you have to put tongs on it. It's a 3-man operation. There's a ton to it. It's very, very difficult to do. So in a curve, it's somewhat manageable. But whereas on a top drive, the directional hand can pretty much do everything himself.
So you might see a couple joints of pipe just shoot out of the
Not quite that. But what you'll see with a Kelly rig is when you pop that out, the lock, and you'll have your drill over there kind of putting a little forward on it. When he pops it out, that thing's going to whip around, and you're going to lose all your wraps. And when you lose all your wraps, now you don't know where that tool face is going to be. You got to count them. There's a lot more steps. And then when you get really far laid out on a lateral, it's a whole different issue of just being able to get the torque down there. With a top drive, you can oscillate it. So you can make left and right, and you're pretty much just reducing your friction factor by keeping the pipe moving back and forth because your ROP is not fast enough to transfer all that torque down there when you're laid out a mile. Seth, how do I do?
Yeah, that sounded right to me.
So those are really the innovation of the top drive came as a necessity with directional drilling. Mm-hmm. It just expedites it, and then you also have the ability to trip faster because you got this big old Kelly 45-foot joint that you got to put away, and it's just better. Mm-hmm. Yeah. And what I missed, Cody? Anything?
Speaking of innovation, yeah, what's coming up? Anything you've seen that you're just excited about? I mean, you keep abreast of everything that's in oil and gas news as far as what you're going to be able to do in the future of your career.
Yeah, I can't really think of anything right now.
No, nothing at all is exciting you. Not,
Seth, what are you guys working on in the background?
Not the bits. Yeah.
Tell me sharks with lasers on their head that we put down a hole.
Oh man.
Yeah, if I told you,
shark laser bit is your thing. That's the way you can coined it here, everybody. That's his bit.
That's through R&D
Shark
already.
laser
So no.
Call it a mud shark though. It's got to be a mud shark.
What about a rock shark? I want it to be rock shark.
All right. Well, if that actually ends up making it out of R&D, then we'll name it a rock shark.
No, you want a mud shark. Look it up.
Fine. Hashtag mud shark.
It could be a rock shard.
No.
Now that is interesting though to think about, like just through the little experience I've had so far in the industry. First here in the Mid-Con, and then second up in Ohio when I was a completions intern with the Cent Resources. I really didn't understand the variety of application and to the operations in those applications.
So can you briefly speak, or long, doesn't really matter, why you have more or less blades on a PDC?
So really it could be a a variety of reasons, but a lot of it is, weight transfer. So you're you're adding one additional blade that's sharing your weight, your load distribution for each one of those cutters. So a more durable design is going to be, 7 blade or 8 blade, and more aggressive 5 or 6 blade.
But you're gonna have a lot more.
You get more cut out of less blades.
That's right.
Well, yeah, but your torque, right? You have the potential for a lot more torque slip with less blades because they can dig in, huh?
Yes, yes, definitely. That's something that, and even cutters plays into that. A little
The
bit.
rake
So,
of them,
yeah.
like there's a crazy amount of technology in a PDC bit and things to think about.
Yeah, and then something that was totally new to me when I was up in Ohio, just understanding air drilling and hammer
drilling
bits,
bits,
and
yeah.
it's just so crazy how much technology there is, and the tip of that drill string, what's on that thing. So
Yeah, so for people who aren't watching, they're not drilling with mud up there; they're drilling with air.
right, yeah, for the most part until
misting.
kickoff point, yeah. So it's kind of a mist, but it definitely is. It's an interesting thought.
How does it work?
So typically you're going to be doing it with a roller cone or a hammer bit. The PDC, there's a lot of important things with having a fluid over a PDC in terms of cutting
And cleaning.
fluid and thermal and stuff like that.
Cooling
So
it down.
yeah, typically you're just going to see that with roller cone. Now there are some operators that are up there that are drilling with PDC on air, but mostly it's going to be your roller cone. But the idea of it is that you're going to have a much higher cleaning efficiency right there with air on air.
Really?
Yeah, and there's not as much of a hydrostatic pressure on that formation too.
Right.
So it's a really efficient way of drilling, and I being a completions intern up there, I didn't really get to ask a whole lot of drilling related questions, but I do cover that area right now with Veril. So
I hadn't really thought about the fact that you have a lot less hydrostatic head. So for applications where you want to not frack your target formation or something like that by being overbalanced, yeah, that'd be great. But the major flaw or the downside, I shouldn't say flaw, is right. If it's too wet of a reservoir, you cannot use it. That's pretty much it, right?
Like I said, they stop drilling on air whenever they get to right before the curve. So now are there formations in between there that you start seeing a lot of water influx? I'm not entirely privy to that, but I could imagine that would probably be a problem.
Has anybody ever tried drilling with air here?
Yeah, in southeast Oklahoma. There's probably been some in other areas, but it's just too wet. Yeah. We drilled some wells in southeast Oklahoma, but we were right. It's like Lattimore County is the cusp of once you cross over that on the east side of it, you can start doing air drilling, and it's a lot faster.
Yeah, way faster.
It's a lot faster.
Cheaper.
Yeah.
I mean, you're saving a lot.
Is
of
it
money
cheaper because you got the compressors and everything out there? You're using a lot of energy.
Saving money on mud.
But yeah, you don't have mud. So
That mud in that section of hole, though, is super cheap. It's just dirty water.
Right.
Yeah.
So, I don't know. You make a good point with the compressors. You got to rent those things, and those are expensive.
and pay for the petrol.
Yeah.
Yeah.
The cool thing about air, though, you mentioned drilling faster. So the typical rule of thumb, heavier your mud is, the slower you're going to drill.
Right.
Because the formation pressure of the rock actually wants to blow the rock apart. So if you get it super underbalanced, like in air drilling, the rock actually almost breaks itself apart. That's where like hammer bits come in play. You just like crack that rock and it like blows itself apart, and you just keep doing that and keep working your way down. So that's why it's so fast, is that there's such a huge pressure differential from the pore space inside the rock to the borehole.
So you're saying the natural pressure of the rock is helping you in this, whereas when you have mud, your hydrostatic head is so heavy that you're not getting that. So, and it makes the tricone inefficient for that reason. But without the mud there, the rock just it's easier to break.
It wants to fall apart because there's nothing opposing it. So
right, yeah, that unequal stress on it.
Mm-hmm. So that's why underbalanced drilling is faster, and then air is just super underbalanced drilling, right?
How often did you, when you're out drilling your wells, did you go, man, if I only had this bit, and you could go to a guy like him and say, I think this is what I need? Or does it go back the other way more often? You're seeing something in your own bits. You're like, if I improved on this, I want you to try this. How much back and forth is there on? Are you asking for the bits to change, or are you thinking that the bits need to change?
So for me, it depended on the area. when I first got up to the Rockies, we needed help with curve bits. So another general rule of thumb, more blades equals better tool face control. But that's not always the case depending on the back rake of the cutters and everything. And sometimes you can have a 5 or 6 blade that's better than a 7 or 8 blade. Yep. So it would just depend. If we were DVRing bits a lot, damaging beyond repair, if we were DVRing bits, then we would say, hey, why do we keep damaging these bits? We need a better bit for the curve, or we need a bit that can do curve and lateral at the same time. Like maybe we need to get more blades on here or decrease the back rake so it'll be more durable over time, and sacrifice a little ROP on the front end to have a 1-run curve lateral. So conversations like that were happening all the time. And like in the Eagleford, we tried doing our intermediate, our curve, and our lateral all in one run. So then you're like, we need to sacrifice a little bit on the front end to have a really durable bit that can go all the way through the intermediate hole and still have good sharp edges on the cutters to be able to make that curve and drill the lateral. So
Cody, why do people, instead of doing 8 3/4, try to do 7 7/8? And a little bit of a backstory on this, because you're using the same size tools behind the bit.
Right.
So by making the idea of the hole smaller, I would think you're going to have a harder time flowing by it, all your cuttings, and you're just going to have more drag.
Yeah.
In general. So why do people do 7 7/8 instead of 8 3/4 for these hole sections?
If they're not changing casing sizes, that'll make the evaluation simpler. But just from purely a hole size standpoint, if you're removing less rock, you have less to dispose of on surface. You're typically going to be pumping less volume because you can get the same annular velocities as you can at a much lower flow rate. So you're not going to need to run your generators as hard. You're not going to need to pump through your tools and essentially maybe wash them out. And sometimes it's for hole stability. If they figure out that they can get more stable hole conditions on the 7 7/8 versus 8 1/2. So
and sometimes drilling efficiency too, from my understanding, is smaller the bit, the more efficient you can drill. So I don't know if that's something that most people target by drilling 7 7/8. I know there's a handful of operators here in the Mid-Con that drill 7 7/8. So
I didn't know they were doing it in the Mid-Con. My experience was with Chesapeake and South Texas that they started drilling a lot of 7 7/8 hole.
Yeah.
How many bits do you guys think you have out right now running?
Running? Well, I would probably,
Curious.
I'd say probably right now running between.
How many rigs are out right now?
In Oklahoma or in
total
United States?
39,
Total US.
including the panhandle of Texas and Kansas,
Do we
I
have
believe.
total U.S.?
You consider that Oklahoma, the Panhandle?
Yes.
Well, they wrap that into the
Careful.
Mid-Con.
I want to make sure you tell everyone in Texas that. You heard it here.
If you are in the Texas Panhandle, we sort of consider you as our cousins.
That's in Everest. That's not Cecily for us in Everest.
But do you think you have 50 bits in the ground right now?
Right now, potentially. Potentially, yeah, 50.
I know some of your field sales guys. I've seen them out at the rigs, and they're always out there. They're kicking butt. Good job.
Oh yeah. We have a really good team. So I specifically cover just the Mid-Con and the Northeast. So having my hands around the understanding of what's going on in West Texas, Haynesville, and stuff like that. I'd be able to tell you.
Are the bits a lot more basin oriented too? Do you
Absolutely.
Think,
Yeah.
You see a lot more of this bit over in the Permian is here, Haynesville.
Yeah, and you can even look at a bit and sometimes tell where it was designed for, and specifically cutter technology.
Like my mom could look at a bit and be like, "Oh, that's definitely Cottage Grove over there." Yeah.
I didn't know where you're going with that. I don't know.
No, yeah. We'll
Mom's
take
a saint.
Verna Lynn Didi is a saint.
Didi. That's awesome. No, but just between the Mid-Con and the Northeast, there are some differences, and sometimes it's operator interpretation of what they're looking for too. You want to kind of have a partnership with them, let them this is what we recommend, but in times past, they're going to have some experience that they're going to lean on as well. So you try to make a recommendation, and if you can work with an operator and kind of have some kind of a partnership, you're going to help them work on production vertical or drill out. We want to be a partner in your success on how y'all are going to perform in this interval. if we can get data from you, whatever that might be, whatever that looks like, that's typically how you'll see your designs evolve in certain areas. So
Are you guys only in the drilling space now? Or are you guys doing, got any tools for any other, like clean outs, anything like that?
So right now we have drilling solutions, which is our PDC and roller cone, and then we have our well construction, which is like cementing equipment and stuff like that, and then we have our completion side. So we have some drill out bits and stuff like that for drilling plugs out and stuff for frac.
How is that different? I mean, I like, and when you talk to someone about drilling out on a frac, you have to know what kind of the plug is, right? If it's a composite or whatever. And you guys, are the bits drastically different for drilling out plugs? Because you're just drilling metal at that point instead of rock, right?
Yeah. So I think for what we have, roller cone typically is what we try to go for. The Slip Extreme is our drill out bit. So that's typically what we go for is the roller cone design. But
I'm surprised by that because you'd be worried about pushing, breaking its hold in the pipe and pushing it down the wellbore, right? So, and with the tricone, people don't know it requires a lot more weight than a PDC to cut, or to break rock or whatever.
Yeah, I know Vero. Whenever I got hired on, they hired on Terry Morris, which is our completions drill bit guy, our engineer there, shout out. And he would be the guy that I would try to lean to on this. But he and I have had some conversation on it because I do see PDCs out on drill outs and stuff like that. So, but roller cone technology has gotten so good to this point. I mean, it's up there with the efficiency of a PDC, and you deal with a lot of other issues with PDCs, like taking too big of bites and having really big plug parts and stuff like that. And where our roller cone drill out design is able to really almost mill out those plugs, with smaller parts,
But you need slick pipe. You can't do that with coil tubing then, right? To transfer that kind of weight?
Yeah.
It was coil tubing.
Yeah.
You can?
Coil
so you can
tubing.
still transfer enough weight with
I like stick
coil
pipe
tubing?
mostly because Knight has it. Stick pipe.
There you go.
There you go. Get yourself a little.
The only time the completion engineers would use stick pipe
Only
was when
time,
I was
don't
at
say only.
Chesapeake.
We love to use stick pipe in our industry.
was when our measured depth was like 24,000 feet plus.
Gotcha.
Okay.
So when you couldn't get that weight down there.
Right, and you got a necks on pipe, right? Whereas coil tubing is pretty much uniform, larger than stick pipe.
I don't know. That went over my head.
All drilling guys in here, by the way. And Matt may be on the completion side. I know virtually nothing about completions. I would love to learn
the
more.
more we go into the future, the more my stick pipe will be used. Coil tubing's probably going on the way out. I mean, really.
You think so?
Night
Yeah,
drilling services.
absolutely.
That's what it's at.
No, so what are you seeing as the future of drill bits? I mean, are they? So I saw a drill bit not too long ago where they had like a little data center in it, and it was collecting data for later. But I don't know how robust that bit was at the time.
Yeah.
But now, data's king. So, like, do you guys have the bits where you can drop the little egg inside of it and collect data?
So I know what you're talking about. There are some bit manufacturers out there that are putting like data.
Don't want to say NOV.
Yeah.
I'm not going to say NOV.
They are putting data, what you could call like a data puck or something inside the shank of the bit. But they're like, we will use a different company that provides subs with data acquisition type devices inside of those at really high frequency. And,
What data are you getting from that?
So really what you're trying to do, we have a program that we're able to take in all your drilling data and straight up evaluate on bottom performance. And we can look at, drilling torque and stuff below and above the motor. We can look at the erratic, for stick slip, big torque bands, or just really kind of the behavior outside of what the bit is seeing above and below the motor. So it's really, it really is, it sheds a lot of light. And I've seen a couple of these data puck analysis, mainly in the Northeast. But the data acquisition side of things, you typically don't see a lot of operators wanting to go down that path unless they really are trying to solve a specific problem, just because it does cost money to also rent those tools. So, but it really does shine a lot of light on what's happening downhole whenever you are able to acquire that type of data, and it is valuable to us because we get to look at it too, right?
Yeah,
so,
you want to know if your bit's working and
absolutely.
what you need to change.
Yeah.
Do you think our efficiencies on bits will, I mean, how much further can they go?
Yeah, so I really kind of lean back on that, the relationship with the operator and what is their goal. Do they want to drill real fast and 2 run this interval, or do they want to stay on bottom, or they want to do this 1 run? So you got to kind of weed out, what are their goals, and then what are we able to bring to the table at that point, because we can give you a really aggressive design and we can make that happen, or we can give you a durable design that's going to complete that interval. So in terms,
the metallurgy will change that much?
oh yeah. Yeah, I think material science is going to be huge for PDC technology in the future. I mean, just the little knowledge I've got to take in from our cutter providers, it's like a next level type material science those guys are digging through. And
the aliens that landed in Roswell are finally paying off.
That's right. Yeah, so there really is no telling. I mean, the type of efficiencies gained left. I mean, there were big efficiency advancements, at the beginning of the PDC revolution in 1970 or whatever, and now it's marginal.
PDC came out in 1970.
Yeah, some of the first PDCs were ran in 1970s.
Where? No way.
Yeah,
Because they weren't commonly used. Well,
Middle East, maybe?
Yeah, it's some verticals. I drilled a couple verticals with them, but nobody trusted PDCs in 12. For me, in Oklahoma.
Yeah. Yeah, no, that's
And little Oklahoma, or our cousins, because I drilled quite a bit in the Panhandle too. I guess Seth calls that Oklahoma too.
no, it's yeah. The one thing I'll lean on here is the intro to my thesis. It says 1970, so must be true.
The hell, you wrote the paper.
I'm not entirely positive where at, but I know they made their debut in 1970.
You know how much easier it was to write a paper, by the way, before the internet?
Yeah.
Well, harder.
Nobody
harder.
check it or what?
Yeah,
That's right.
That's the part.
That's right.
So he can make up.
Yes.
It's both ways, right? Because it was harder because you actually had to read a book. But at the same time, it was easier because you could cut and paste. Yeah. And if you had to read a book, no one was going to check that.
Right.
So,
Yeah. Tell you one thing I'm excited about for drill bit technology is better dull grading.
what does that mean?
What is that?
So dull grading is when a bit goes in the hole, it's obviously brand new.
Right,
most
0
of
to
the
8,
time.
right? Or
Yeah.
1 to 8.
Yeah. Well, no, 0 to 8.
It is 0
Yeah,
to
0, it's essentially still brand new. But with roller cones, it's easy-ish to dull grade them because a 0 would be you have a full spike left right here.
Okay.
An 8 would be you have no spike left here.
Missing a cone, maybe, too.
Yeah, you're missing a cone. You can obviously denote that on the dull grade. But on a PDC, it's trickier because they use the same thing, right? So if you have the full diamond compact, that's a 0. If you have no diamond compact, that's an 8. But a completely worn out diamond compact might be a 2.
Who pays for
3.
that? The operator or the bit company?
If it's just the diamond compacts themselves, each one of the cutters, I'm assuming just the bit company pays for that because that's not DBR. Those cutters can be replaced.
So you're telling me you're just excited for a new methodology?
Yeah. So I don't know if Veril has anything like this going on, but Torex is using, I believe, lasers to accurately measure all the different angles and the wear on every single cutter. So then you can be like, well, it's not a 1-2 dull grade. It's this dull grade that's much more in depth. Cutter.
We need to beef this one up.
Yeah, cutter 17 on blade 4 is worn down, and so is cutter 5 on blade 3. And it's like, why is that worn down? It's like,
Are they in the same place? That you said.
I don't know. I made that up.
Oh, okay. So you're just excited about a new way to look at it, but that's not even. That's still back at Seth's office.
It's
not out in the field. It's not a different methodology in the field.
Correct. It's how to improve PDC bits after each run. It's not going to help you on this run, it'll help you on the next one.
So instead of just blankly saying it's a 6 because we had worn cutters, but that's just worn cutters instead of saying where the worn cutters are.
And you could have 10 different people look at a worn bit, and you'd probably get 10 different ratings.
Your first two numbers are going to be your 2/3 from the interior, and then your 1/3 from the exterior. So you're going to have like a 1-3 or something like that. But it is very inconsistent. So it's all about interpretation.
Yeah, subjective.
And whenever you have a scale from 1 to 8, there's a lot of room for interpretation there. And
that's why I can't watch anything in the Olympics that they don't score points because I don't want someone to tell me how that dive looked. I don't.
The problem is
it's got to be a point.
0 to 8, like I said, 0 would be a brand new cutter. 8 would be a no cutter. Like it's all gone.
Right.
So even a 4 out of 8, that cutter is useless. A 3 out of 8, 2 out of 8, it's still it's pretty dull.
Yeah.
Like Oh, sorry, I'm not close enough. Even a 3 or a 4 out of 8 is a very dull PDC cutter. So it's just not consistent with how you need to grade these bits as it is with PDCs. So getting that new technology in there to be able to grade those better to improve faster.
So say that improve faster. When you come up with something like that and say, hey, so this is where our problem is, how fast can you change the design and get a new one out?
Oh, I
2
mean,
weeks now. The technology is astonishing. You guys have
Yeah.
your 3D modeling, and you can design a new bit based on his observations within
Yeah.
a couple weeks and get it back out to him now.
yeah, definitely. I'd
That's
say
fascinating.
4 to 5 weeks.
Now, how do you make a bit? Is it billet? Or is it a mold?
So it depends. So you have your matrix body and your steel body bits.
What are the difference?
So a matrix body is going to be it's a metallurgic process where you get graphite, and you have these huge graphite cylinders, and you're drilling out a negative of what your bit is going to be, and then whatever the composition is that the matrix that you're gonna fill that up with. Then you have the negative spaces for all the features. And then you have a binder that sits at the top of that. And then you send that into an oven. And that binder drops all the way through all your composite material until it's fully cooked, really. And at the end of that is when you have your matrix bit. Now, for a steel body bit, you have these really awesome, it's like 6-axis lathes, and these things are so dialed in. You'll have to have a legit programmer put that type of information in. But you put a huge steel block into one of these mills, and it just goes to town, and then it just goes based off of what your algorithm is to achieve that geometry within.
You have all the access you need.
So yeah, and certain areas like one or the other, depending on repairability, steel body is going to be a little more repairable, but they say the matrix body is a little more durable and a little more rigid and tough. So it is an interesting material conversation because there is a lot to that. And
What
even
about the possibility of 3D printing bits in the future?
That'd be cool.
that would be cool.
So there are not a lay, but there is a machine that exists in today's technology. It's quite expensive that can 3D print.
Metal.
Yes.
Yeah.
I bet that's coming in the future. I don't know how near in the future.
Well, like you said, it's going to be about the metallurgy science.
Yeah, for sure.
The immense amount of heat. Gosh.
It would probably have to be
Yeah.
matrix bits that would be 3D printed.
Yeah,
But
I
I'm no
mean,
metallurgist, so I don't know.
I don't know. I probably, I'm not sure honestly, but I know the 3D printing it'd probably be easier with a steel body because, steel, depending on the type of steel content you're going to have, getting it to what is known as the eutectic point, where a bunch of particles exist in equilibrium of fluid and a solid. So right at the temperature between where that steel is a fluid and a temperature is where you have to exist. And then the cooling process with that, there's a whole aspect to cooling. So you could really end up with a much more brittle bit if it cools too fast. Mm-hmm. If you were to 3D print one, if you cool too slowly, you could have a real ductile type material. But steel and the matrix stuff there's a lot of material science in that I think probably is overlooked in reality. And
So Barrel's going to be the first 3D printed bit.
potentially.
I mean, maybe I could sit out on a rig and the engineer can type in, the code and I'm going to order my bit, but
on location.
I have my bit delivered on location.
You're gonna have a hell of a furnace out there.
Why not?
Yeah. It's a
It's a little
saying.
arc welder. A little arc.
Yeah.
furnace, I don't know.
Yeah. I mean, just save a hot shot fee. That's all.
There you go.
All right. So this is our show, everybody.
I got
Talking
one
Energy
more
Show.
question.
I'm going
and
to
I wanna
let
finish on
Jeremiah,
that.
as always, wrap up this show with one more question.
Yeah. By the
Probably-
way, great question on that last one.
probably
I don't know
5
if that's
questions, isn't it? Yeah, that's fine.
It's actually a 5-part question.
5-part questions.
So, I'm no engineer over here,
Yes,
but I
you
was just
are.
writing down some simple numbers. There's 4 of us in here, and I guessed our ages. I know Cody's and Matt's. Seth, I kind of know yours just because I've known you a couple of years too. So I know you recently graduated.
Yeah.
So I believe our median age in here, or average age, actually, it's average, is 36. What is the average age of everyone you work with? Do you think, or median wage? Let's cut out the CEO or someone else.
Are you talking
and
about the
the
great
youngest
crew
guy.
change?
So there's
now?
5
I'm leading up to
there's 5 or 6 guys in my office, and I'd say the median age is probably 40 to 45.
40 to 45?
I'm the youngest by far.
Cody, your peers, I know you can't speak about your new endeavor, but your
Yet.
prior endeavor, the people you at least immediately saw every day?
Yeah.
What do you think the age was?
Well, we were a very young group over at Chesapeake, all the drilling engineers. I would say the median age was probably 28 to 30.
28, and so your supervisors were probably the oldest guy for the most part. I knew a couple older engineers, old crotchety guy like Jerry Bowen, and a couple other guys that were
even when
engineers.
the last couple of years he wasn't even there.
Right.
Right?
My good friend Peter Burke.
Yeah, the oldest drilling engineer, not talking drilling
younger
manager,
than me,
was
by the way.
probably James Bland, and he's what 36, 37.
He actually, I bet you he's 40 because
I
he went to
just
school with
talked to
Jason.
James.
Yeah.
Yeah.
He's growing berries.
He's running a skid steer
Dingleberries?
right now.
Yeah,
Kicking
he's doing a lot
back.
with his
He's
land
doing a
management
lot.
company.
Oh, is he out of oil and gas?
No,
For now.
I mean, kind of. He's
Yeah,
doing
I
his
mean-
berry farm and doing land management,
What
like
kind of
running
berries?
skid steer.
Strawberries.
Blackberries,
Oh.
all kinds of
If
things.
it's a berry, he
I
can
have
grow it.
an acre of blackberries at my house, by the way.
I'm
So
coming
if
over.
anyone wants to
Doing
come pick
wine?
them, yeah, you're what?
Doing wine?
Blackberry wine? I haven't
He's
thought
feeding,
about
that'd be
it.
he's feeding his
delicious.
Sweet.
alpacas and his ass.
Yeah, they eat a lot of them, and I have a miniature cow now too, Linda
Oh, you have a
bovine.
new. You have
Yeah.
a
I need to
new
come see
animal.
Linda. So does
Yeah.
Amanda.
Yeah.
For those just tuning in, Jeremiah has a zoo at his house.
Miniature zoo. I only do miniature animals.
Miniature.
at
Yeah,
the
he's got
full
4
size.
animals right now.
Yeah.
Yeah,
If you have
they're
a-
all minis.
If you have a stray animal out there,
It has to be mini though,
A
When
mini
you get-
stray animal.
and I still don't want
When you
it.
get past 7 animals, it's no longer miniature.
Yeah, well,
It's
they're all,
actual
what
zoo.
if you stack them up?
God bless your wife.
Mm-hmm.
It's one standard.
So if you want to see a
Seven.
cool video, and I think you got some views on it too.
Oh yeah, we got 9,000 views on that.
Yeah, Duke, his little puppy came over, and the donkey, the miniature donkey, old Louie, and him were running up and down the fence line.
Yeah.
Now it looks really cute, but if old Duke was in there, old Louie
could-
would have tried to kill
Yeah,
him
he could have stomped.
murderously. Yes, in no way
Yeah,
would it have been
poor
positive, but it was cool there. Matt, what is your median age for your peers that you work with?
At night? Mm-hmm. I don't know. Probably 36.
36.
Sure.
All right, and Cody, you said it was in the 20s or 30s?
Yeah, I mean, we had a lot of the engineers there were younger than me, so they were in their mid to late 20s, and there were only a couple people older. But if you want to bring drilling managers and drilling VPs into it, it'll
Aubrey.
bring it up. But
And I only bring this up. Our next show, we're going to have Joe Berbetti on and someone else, but we're going
be
to talk
good.
about the great crew change, which
wow.
we've all experienced at this point. And it's definitely happened.
I've never been fired. I've always moved up in the world. So
I don't want to say I moved up, but
You've
I've
moved
never
up.
been fired.
Yeah. We all
technically not fired.
keep- yeah,
let
no,
go.
yeah. Man, that's so. Yeah, you don't deserve to be fired.
Thank you, man. I think that's it, unless you got something else.
No,
So tune in next Tuesday is when we'll actually record it. I don't know when
I don't
Matt
know.
will drop it.
You never know when we're going to drop these for your enjoyment. But hey, Cody Godsel.
Oh, wait, one more thing. I wrote this down to put out there, and this is only for anyone that actually listens all the way through.
If you listen all the way through, this
Yeah,
is
don't
keep
nobody give it away, and probably no one cares either way. But we need a producer, and it's for nothing else than Cody was trying to get the Woodford Reserve over there to pour in his cup, but he couldn't. If we had a producer, that guy could have done that.
Hey, you're close enough to the OSU youth, if you will. Do you think there's anybody over there that would like something on their resume and call the Talking Energy Show producer on their resume something like amazing?
That'd be awesome.
Absolutely.
They also
If
need
you
to be
put-
ready on a moment's notice.
Yeah.
Because Matt's like, "Hey, we're
Usually
doing this
Tuesday or
tomorrow."
Wednesday.
because Jeremiah and I are both taken. It
Yeah.
cannot be anybody that's going to tempt us.
Yeah.
So
To say or do anything that will get us in trouble. in
Yeah,
this
for
building.
sure. Yeah, y'all need a producer. That'd be sweet.
yeah, it
But,
would be sweet. We're missing a producer. By the way, did you know there's another show called Talk Energy?
Listen, okay.
So
here we
you
go.
ripping them off, trying to steal their viewership, or
Nope.
were we
Hey,
first?
we have a
So
ING.
I have an idea. If Max comes in here to this show and does his show with us, we will change the name of this show.
to talking. We'll drop the G.
Get closer.
I mean, we could call this and go back to the original idea anyway, the oil field tailgate, where we are fans.
Man, yeah,
that's
do
cool.
it.
We're fans of the oil field.
I like that.
I absolutely love that, Matt, and it's great for Matt. Doesn't plug this enough, but he does an amazing job. How many years have you been doing that, by the way? And what that is the most badass
It's awesome.
party
At
in-
Othello's?
Yeah, and OU.
Yeah.
Seth is only allowed to come one day a year.
That's right.
No,
and it's
he's-
what, every other year?
He's all in now. In fact,
I'm all in.
While I have you, I'm gonna do a little plug, and then we're gonna get rid of the show and
Can I do a
let
plug
you guys
real
move
quick,
on
too?
today. And you can do a plug too right now. Talk
Oh.
about what's your guys.
Oh, hey, you gonna get some more views on Duke?
No.
Well, okay, you guys go ahead and plug your stuff.
Yeah, so I wanted to go ahead and give a shout out to the Colorado School of Mines golf tournament. Usually we do it in the spring, but because of lasting COVID, we didn't do it last year. We didn't do it this spring, but we're going to be doing it Friday, September 24th.
At Rose Creek?
Yep,
again?
it'll be at Rose Creek. Starts at 1 p.m. We don't have very many people signed up. We're, a little over a month out.
Okay,
so if you want to get signed up, we'll put the link on. I'll get with Matt and we'll put the link on.
Yeah, put
on
it.
the
We
page.
can put it in or we'll just put it as a
Everybody
message
watches
on
it
there.
right now.
It's,
The oil field golf tournament.
Yeah, it'll be
Pretty soft
140
out.
per player or 110 for young alumni, those graduating after 2016. So we need teams, we need sponsors, we need catering sponsors, prizes, all kinds of stuff. So
Hey, congratulations for getting hired to your new job. by the
Hey,
way.
yeah, and future marriage. By the way, I get
Cody's
to enjoy
getting married.
bachelor party.
yeah, I got
weekend.
bachelor party this weekend. So
Amanda, watch out. I mean, you got a keeper, and you are a lucky
yeah.
woman. I mean, really, you should just always be thanking Cody for.
You know,
Yeah,
I've been,
you should marry him.
So a couple
should
people
marry
have asked me what I'm doing this weekend, and I was like, I think I'm going on my last bachelor party ever because it's
Last one, huh?
Well, only just because you get to an age, and eventually it becomes divorce parties, or hey, let's just go
man.
get beer.
People party over that?
It's a thing.
No way.
You'll get to experience it, man. Everyone,
Yeah,
get
you're
you a
young.
divorce
Hey,
under your
you're
belt.
young,
You'll
yeah,
get one. Yeah.
fulfilled.
Knock on wood, you'll get
Get out of the
to.
way.
I hope you never experience it. I hope all your friends live
I think
happily
it's
ever
more
after.
women do more divorce parties, but guys are like,
Yeah. It's,
I'm going through a hard time. Let's go get drunk.
Do you
and
have
then
a-
like,
do
hey,
you
I'm
have
getting
a
hitched, but we're gonna do it in my
significant
backyard
other
this
right now?
time.
I do. I got married in April.
Oh my
Congratulations.
gosh! I didn't
Thank
know
you.
this.
Very recent.
Congratulations,
Yes,
buddy.
thank you.
You're so young. You
I
didn't even
know.
play the field. She just locked you down. She's like, "Oh, he graduated. He's got a job. I'm locking him down."
That's right. Well, at first there was a little bit of a 8th month patch where she didn't know if I would get employed, so I was a sugar baby for 8 months. It was
Nice.
incredible. So
They call it a kept man.
Kept
by
man.
Is
the
that
way.
what it's
No,
called?
It's a kept man.
It's called Man
Oh.
of Leisure.
I like that
Whoa.
one too. Either one is
Man
nice, but
of
it
leisure.
adds a little bit of class to it instead of saying, I'm unemployed.
What about it? Well, that's why I always said sugar baby.
There you go. That
So,
works.
All right, so I'm gonna pitch my Oilfield Tailgate sponsorship for Barrel right now. Okay.
Yeah.
So every home game in Norman, we have the largest oilfield party in Oklahoma. Every home, we put it in Norman just because more bang for the buck, right?
Definitely.
So if you pitch in as a sponsorship, it's $2,500. That's 6 parties where you get to invite all of your current and potential customers and friends, family, and say, hey, if you're part of the oilfield or you support us, come down. Free food, live music, open bar at Othello's in Norman. Bring your signs, bring your swag, anything that promotes your company. Put your logos, all over all of our social media platforms, which includes the website, Facebook, Twitter, LinkedIn. I mean, all of them.
yeah.
So
Yeah.
Cody, I was
we go.
trying to get a sponsorship for Trace, right? And I volunteered our car. I was like, no, and I told Matt, I was like, Matt.
Yeah, we put his logo on.
Oh, I know, but I wanted Matt to have a picture with thumbs up, just his head. Yeah, I wanted.
I do love that.
I do love. But he wouldn't do that. We did get a logo.
Guys, I had to get skinny 1st.
We were there. Can we not
Yeah,
have
you
your
did
face
it.
on there?
My photograph would cover your whole car back then. Now it's just like a door.
Yep, thank you.
All right, guys. Thank
Yep.
you. Tune in every time to Talking Energy
Yeah.
Show. Or if Max, if you come in here, we're changing this to Oilfield Tailgate and giving up Talking Energy.
Do you think
Show.
Max listens?
Absolutely. Why would he not love our show? Like I
That's a
love
good
his?
point. We
I
are
follow him
syndicated.
all the time and love his shows. So, but I was made aware by a mutual friend of ours that he might be annoyed that we started. And by all means, this came about organically. Jeremiah, we're in here in this studio,
Just talking energy.
just talking
Talking
about
energy.
oil and gas. And he's like, "What are we going to call this podcast of ours?" I was like, "I don't know, like." Energy or petroleum, like we went on and on and on. Finally, we just wrote down, how about Talking Energy Show? We'll just go from there. I bought the website. I went out.
Don't let Matt get excited about that. How many websites do you own, Matt?
About 15 websites. They all, hey, by the way, they all point back to oilfieldtailgate.com. Every single one of them just oilfieldtailgate.com.
you got here by accident. I think you meant to go here.
It's so like that, but
They all redirect to
It
one
used to go to
location.
Talk Energy Show, but now they all come back
Joe
to
Biden
us.
for president.com.
oh, gosh. Yeah. So anyway, at the end of the day, all this is supposed to point back to Oilfield Tailgate and help the sponsors out. Like Barrel's going to be with Seth's check right after this show.
That's
All
right.
right, cool. Man. Oh yeah.
You can do it in
When does
payments,
that
right?
check get, Rick?
Do it in payments, absolutely.
Heck,
Yep.
this is a good year. It should be an
Low
easy
payments,
one.
That's right. Yeah.
Hit up all of us on social media. Please connect with us on LinkedIn. We'd love to chat with you about what we're doing and support Jeremiah in his new endeavor.
Yeah.
Jeremiah needs a job. I'm just still for Chuck
Jeremiah
Yates.
needs a job. Thank you, Chuck Yates, and everybody that's come in, our predecessors. Anyway, God bless. Take care.
Adios.
Bye-bye.